This is a short, festive themed interactive session for teachers of all subjects who struggle with mathematical elements of their own delivery. My name is Charmaine Phelps and I'm a Provider Development Officer here at NCFE. I support centres with functional skills, essential digital skills, qualifications, but my specialism is maths. This session is not qualification specific. However, the maths examples I'm going to go through are functional uses of maths at level 1 and 2. So today's topic areas are shown here on this slide. And what I'm going to do is for each of the topic areas, I'm going to give an example for each topic, and I'm going to give you the opportunity to solve and answer in the chat, or feel free to simply say, oh, I struggle with this, and then I will go through a worked answer. Now, all of the examples have got a festive theme because it is nearly Christmas and I celebrate Christmas. I'm very excited. And it's also to illustrate that the maths that we teach is relevant to everyday life. And for those of you who have already mentioned in the chat that what you want to do is think about embedding maths, then some of these examples actually may give you some ideas on how you can link the maths that you do or the vocational subjects that you do, link the maths together. So hopefully this will inspire you to contextualize maths according to the subject you teach. So we're going to jump straight in. So we're going to look at percentages. So here's an example. So I'm going to give a gift of some jewellery. Fave Jewellery is holding a 15% discount sale. How much will a £45 necklace be in the sale? And I'd like to invite you to either tell me in the chat or crumbs, I've got no idea how to work this out. Oh, somebody is straight in there with an answer. Lots of you straight in with an answer. You were very fast there. I'm wondering, let me know, are you using a calculator or are you doing this in your head? Because either way is absolutely fine. Anybody is welcome to have a calculator beside them, because some of the both you did it in your head and then checked with a calculator, maybe. Very good. So we've got an answer, but in our head and on paper. Yeah, okay, good. We've got an answer there, but for those of you who've not been very brave or not as brave to put an answer in or is quick off the mark, don't worry, we're going to work it through. So when it comes to percentages, there are tons of different ways of calculating percentages, but the important thing that you need to remember is percent simply means out of 100. So you've got the per, and then cent, which is the starting word of like century. So it's out of 100. And if you always think of it in those terms, then you shouldn't go far wrong. So for this example, right, here's one method. What I might do is try to find 15% and take that away from £45. So here is our whole, okay? Now, it would just take me too long to split this whole into 100. I'd have too many lines. So for convenience sake, I've split this into 10. Okay, so each one of these is worth 10. So here's my whole, £45, and I need to take away 15%. I do know, however, that 45 divided by 10 is £4.50. So each one of these is worth £4.50 on my bar model. And if I draw a line here, it's this much that my necklace is going to cost and this much that is the discount. So if I add together £4.50 plus half of £4.50, which is £2.25, then I get £6.75. So that's the discount. And if I do £45, take £6.75, then just as the people put in the chat, I reach £38.25. So that's one way of doing it. And quite often having a picture can help can help to understand, and your learners will find this as well. Another method I might do is potentially faster, particularly if I've got a calculator. I can just simply find 85% of £45 because we know that percent is out of 100. If the discount is 15%, then 100 take away 15 is 85. So this amount here is 85%. So there's different ways of doing this. My always go-to when I'm finding a percentage is I tend to divide by 100 first because it's out of 100, and then multiply by the percentage I'm trying to find. So divide by 100 or multiply by and then multiply by 85. And some of you may be quite quick and be able to spot that a faster way of doing that calculation is in your calculators, just do 45 times 0.85, or if you've got a percentage button on your calculator, feel free to use it. And that goes the same for functional skills assessments as well. So who's put this here? Admin. You can. I don't know if you're able to change your name in Teams to what your actual name is, but that's okay. Same method. 10% is £4.50. Half of that is £2.25. Taking that away. Perfect. Okay, so let's move on. Okay, this is a slightly more complicated percentage question. A winter coat is £41.60 after it's been reduced by 20%. So how much would the coat have been at full price? And please feel free to give me either an answer in the chat, or I've got no idea in the chat, or does anybody recognize some? I do know that some people in this session are actually functional skills teachers, and you might recognize what type of a question this is. And I think we've got some answers here that if you check those answers, and the way that you would check this is you would do a reverse calculation. So I've got two answers, and this is common. Okay, it's a common error for this type of question. Look at your answer, £49.92. That's three of you now, so it's common. Okay, and take away 20% from £49.92. If you end up with £41.60, brilliant, you know it's the right answer. But if you don't, can you recognise what you've done wrong? Okay, and thank you very much for popping the answers in there. I really, really appreciate it. But this is a common error for this type of question. So does anybody want to tell me? I can't see anybody writing at the moment. Does anybody want to tell me what mistake you think you've made? Otherwise, I'm going to go through the worked answer. Okay, so anybody who teaches functional skills will recognize this is a reverse percentages question. Okay, and when you're dealing with reverse percentages or original value questions, then simply taking 20% off of £41.60 is and finding 20% of £41.60 and adding that on is not going to give you the right answer, and I'll show you why. So when we're dealing with original value questions, and these do come up, they come up in real life, they come up definitely in functional skills, and they may come up within the subject that you're teaching. The way I do it is I take it in steps. Now we need to express the discounted amount as a percentage of the original. So the original is 100%, okay? And if I take away 20, that means £41.60 is 80% of the original. And you might understand better if I show you in a diagram. So here we've got our bar model. We don't know what this is, the original amount, but we do know that whatever the original is, it's 100%. Okay. 80% is £41.60. If what some of you have done is you found 20% of that £41.60. So you've taken this as the whole, okay? But this is not the whole from this green line backwards. This is 80% of the whole. So what we need to do instead is if we divide to find 1%, so these are my 3 steps. I always do my little way to remember this for an original value question is Poo de moo, poo, percentage of original, D, divide to find 1%, and then moo, multiply by 100. So £41.60 divided by 80, so here, gives me 52 pence. So that means each one of these little squares here, because I've split my whole into 10, each one of these squares is worth £5.20. Okay. You can give me a thumbs up if you're kind of following this, or a thumbs down if you're like, Charmaine, you've totally confused me. Can you see? So £41.60 divided by the 80% or divided by 8 is going to give me the £5.20. And then it's this little bit extra is the original value. So I multiply the 52 pence by 100, or I multiply the £5.20 by 10. And my original price is actually £52. Okay, because that's what I've taken off. I wanted to reduce this by 20%, not find 20% of this and add it on. Does that make sense? So to those people who go, this is kind of the only trick question, if you like, because original value questions typically trip us up. All right, they do trip everybody up. So but give me a thumbs up, or those people who gave me an answer, please continue to give answers. Is everybody, oh, we've got a thumbs up. Okay, so we understand that. Thumbs up. Thank you very much. Perfect. So beware of questions like that. So that's an original value question. And again, if in doubt, using a bar model can really, really help to understand what it is you're trying to find. There's a quicker mathematical formula for finding original value, the original value. However, I just find it easier to take it in steps, nice and slowly. Okay, a lot of people mentioned fractions in their the challenging areas in the registration form. So here we've got a potentially real life example, apart from the fact that I have 2 cats but no dog. So in my house, actually, can you have the quicker formula, please? I'll send it to you in a chat if that's it. I'll send it to you afterwards, actually, if that's okay. So thanks. Okay, cool. So in my house on Christmas morning, Father Christmas puts Christmas tree decorations on the tree. So this is what's happened here. So 24 chocolate ornaments appear on the tree. Brilliant. The dog eats a third of them. The cat pulls down a quarter of them and they are shoved under the couch, never seen again. How many are left expressed as a fraction? So I'll give you the opportunity to answer this. And again, you can give me an answer or you can just say, I don't know, it's fractions. I'm not very good at fractions. This is why I want help with it, please. It's up to you. Oh, Paola. You've done exactly what I've asked. You've given it as a fraction. Any different answers to Paola's 5/12ths? Let me get the chat back. I've got 2 with 5/12, 1 as 7/12. Okay, and thank you very much for putting answers into the chat. I very much appreciate it. And I don't know about you, but I tend to find I learn things better when I feel free to make mistakes, and quite often I actually remember something that I got wrong better. So let's just have a little look. Right, so we're going to have a look at 2 different ways of solving this. So first thing, I can just calculate the numbers. So the dog is going to eat a third, naughty dog. A cat pulls down a quarter. So I will need to work out a third of 24 and a quarter of 24. Okay. So 24 divided by 3 is 8. So the dog has eaten 8. Rascal. 24 divided by 4, a quarter, is 6. 6 ruined by the cat, or potentially covered in dust underneath the couch. So that's how many have been damaged. So how many have I got left? 10. I've got 10 that's safe to eat. But the question is asking me to express this as a fraction. So I can just do for any fractions. So any, like, fractions don't have to be complicated. It's if I've got 10 out of 24, then I can simply write 10 out of 24. So 10 as the numerator, 24 as the whole, the denominator. So 10 24ths, which quite rightly, as some of you have done, is you've simplified that to make it 5/12. And when we're simplifying fractions, we're just making them the lowest values that we possibly can. So what goes into 10 and also into 24? The only thing I can think of is 2. So if I divide top and bottom by 2, whatever I do to the top, I have to do to the bottom. So divide 10 by 2, I get 5. Divide 24 by 2, I get 12. So 10 24ths is equivalent to 5/12. 5/12 is the answer in its simplest form. Question didn't ask for it in its simplest form, so 10 24ths would be acceptable. But in general, when we're dealing with fractions, we tend to give the simplest form. And if you struggle with fractions, or if you have learners who struggle with fractions, using real objects, real things, if you're able to get a cake, a pizza, a chocolate bar, dealing with real things, because we quite often, can I have half of that, please? We understand it when we're talking to one another and it's around the dinner table, but for some reason, when we see fractions written numerically like this, that's when a lot of learners, a lot of people get kind of a little bit anxious. So start with objects and then move on from there. So there's our first method, calculating the numbers. Our next method is we're going to do a fraction subtraction. And I think whoever it was who put in the chat the 7/12, I think what they gave me was the correct answer for how many got ruined. Because if we look at our fraction subtraction, ultimately, the 24 chocolate ornaments is 1. That's our whole, okay? So although our 1 is 24, because it's split up into bits because there's 24 of them, that is our whole, okay? So we've got 1, take away a third, and we're also taking away a quarter. So we can do a third plus a quarter. 1 take away a third plus a quarter. Now, trying to do a third plus a quarter, the only way you can do that is by making the denominator the same. And what I do, therefore, is I look for the lowest common denominator. And it just happens for this that the lowest common denominator, 3 times 4 is 12. So I know that 3's go into 12, and I know that 4's go into 12 because 3 times 4 is 12. So I can rewrite my fraction subtraction. I've now got 4/12 plus 3/12 because I multiply the bottom by 4 to get to the 12. Therefore, I multiply the top by 4 As long as I do the same to the top and the bottom, that makes it equivalent. And similarly for the quarter, I multiply the bottom by 3, and therefore I multiply the top by 3. So I then have, and 1 is no good as well because I need it to be in the same, written in the same format. So 1 as a fraction with a denominator of 12 is just 12 over 12. So I've got 12 twelfths minus 7 twelfths. So 4 plus 3 is obviously 7. So 12 takes 7 is 5. So again, I've got the same answer, but I've just gone about it differently. Okay, does that make sense? There's lots of other things that we could do with fractions, but we're sort of just having a little introductory go at doing some fractions today, and hopefully I'm not confusing you more. But as a general rule, if you're dealing with fractions, if you've got learners who are confused with fractions, deal with objects first. It'd be really helpful. Okay. Right, we're going to move on to formulae. And in GCSE maths, learners have to do all sorts of algebra. In functional skills, the algebra is quite limited, to be honest. All they need to do for functional skills maths is be able to substitute into a formula and also follow the order of operations, which we call BIDMAS or BODMAS, which stands for, do you guys know? If you don't know what that stands for, ask me. But otherwise I'll assume some knowledge. But like this is numeracy necessities. This is a for specifically for teachers who struggle with maths. So don't be shy about saying, I've got no idea what you're talking about, Charmaine. Okay. So here we've got a formula. This is a realistic formula, and I know it's a realistic one because I Googled to find it. It's slightly different to the formula I use for cooking my chicken. Thank you, Megan. Yeah, BIDMAS is brackets, indices, division, multiplication, addition, subtraction. So it's the order in which you do you perform the operations. So for this example, turkey cooking time, T, in minutes, is given by these formulas. So there's two formula here. So T equals 20k plus 70 if k is less than 4. So this symbol means k is less than 4. The way I remember these symbols, right, because if you said write me the symbol for greater than or less than, I actually might get a bit confused because I always think of it as the one, the pointy end is the small end, and so it's pointing at the smaller one. So k is less than 4 here. 4 is the bigger one because it's at the bigger end. Or the formula changes if k is greater than 4 to t equals 20k plus 90, where k is the weight of the turkey in kilograms. How long will a 3.2 kilogram turkey take to cook? So if you'd like to pop an answer into the chat. Okay, we've got some answers coming through. By all means, don't assume that the answer that you can see is correct. I'm not going to say if it is or not. If you can do, and if you can do this, brilliant. What you are doing is you're substituting into a formula. And I kind of think as well that those people who say that, you know, they get confused by algebra, I wonder if it's because, so for example, at GCSE, you know, you might have to collect like terms, and quite often the formulas don't necessarily mean anything, and so that's why it becomes even more confusing. You've got 6a plus 4b plus 2y equals z, and then you've got to solve it. But in general, all you need to do is you're substituting the numbers that you've got for the letters. And if you're a vocational teacher, it's highly likely that there will be formulas that you do have to your learners have to use. So being able to just have a bit of confidence around substituting into a formula can obviously be helpful. So we've got some answers. Let's have a little look. So this is the one we're going for. So k is less than 4. So this is the formula that we're looking at, 20k plus 70. So all I need to do is substitute the numbers into the formula. So instead of t equals 20k plus 70, it's t equals 20 times 3.2 plus 70. And this is where BIDMAS comes in, because if I do things the wrong way around, so if I do 3.2 plus 70 times 20, I'm going to get a very different answer to if I do it the right way around. So following BIDMAS, so that's brackets. There's no brackets, I don't care. Indices, that means anything to the power of, like squared or cubed, or but there's none of that, so we can ignore that. Division, there's no division, so we can ignore that too. Multiplication, okay, right, we'll do the multiplication first. 20 times 3.2. That's going to come first, and then I do the addition. So 20 times 3.2 is 64 plus 70. I've got 134 minutes, which, well done. Yes, you did have that right from the outset. Quick off the mark, 134 minutes, which we can then convert into 2 hours and 14 minutes, which is exactly what you've said. Thank you. So is everybody okay? So all we've done is we've substituted into a formula. This particular formula is quite a straightforward formula, but it is a real formula, okay? So it's useful, okay? The maths is everywhere. You will come across maths on your in your Sunday dinner, if not in any in any Christmas dinner. So right, now we're going to look at rearranging equations. In truth, you don't need to rearrange equations for functional skills maths, however you do for GCSE, and you may well have to do in whatever vocational subject that you guys are teaching. So here we've got Kris Kringle cars. Calculate their fares for the 25th of December, and it's probably going to be the same charges for the 31st of December as well, or the 1st of January. I never know which is the double time days. But they're using the formula F, so the fare, equals 2 times 5 plus 2.5 m. So fare is F is the fare in pounds. M is the number of miles. Okay, and it's a realistic formula because you tend to have your standard charge plus however much it is per mile, and on Christmas Day everything's going to be doubled. The fare comes to £46. How far was the journey? And okay, in real life we'd know probably how far the journey was, and we'd just be worried about the money. But for the purposes of now, we're going to rearrange this and try and work out how far the journey was. And it's in miles. So the fare comes to £46. How far was the journey? Can anybody tell me in the chat? And I appreciate that some of you might be making notes on the slides that I sent earlier. Some of you could, understandably be sitting there thinking, I'm just going to wait till you give me the answer, Charmaine, okay? Because that's why I'm here. So for those of you who can calculate this, go for it. And for those who would prefer to wait, that's fine. So we've got some answers coming through, and I'm not going to tell you whether you're right or wrong because I want other people to also have a go. Just go back to find where my chat is. Here we go. Okay, right, we've got some answers coming through. So let's have a little look. Right. Now, what we need to do is we need to rearrange this, okay? Because we know what the fare is, but we don't know what the miles are. And we call this the subject. The one that's sitting all by itself, we say is the subject of the equation. Really, we want the m to be sitting all by itself, so that all we've got to do then is substitute in for the f. But for the purposes of this particular equation, it's going to be simpler if we expand the brackets first. Not always, okay, but for this one. So when we say we're expanding the brackets, it means whatever is outside the bracket, okay, there is no times symbol here, but we know that 2 sitting outside a bracket means 2 multiplied by everything inside the bracket. So 2 times 5 is 10. 2 times 2.5m is 5m, okay, because 2 times 2.5 is 5. So here we've expanded the brackets. Already the formula looks a little bit nicer to deal with. Now what we need to do is we need to rearrange the formula to make m the subject. So what we basically have to do when you're rearranging a formula is similar with when you're finding equivalent fractions. Whatever you do to one side, you have to do to both sides in order to keep it balanced. I want m on its own, all right, but I've got this 10 plus 5m. So the first thing I'm going to do is I'm going to take away, if I take away 10 from this side, then that's helping me to get m on its own. So if I take away 10 from this side, from the right-hand side, I also need to take away 10 from the left-hand side. So f take 10 equals 5m. Now, the opposite of multiplication, we've got 5 times m here, is division. So if I want to get the m on its own, I need to divide this side by 5. That'll give me m on its own. If I'm dividing this side by 5, I also need to divide this side by 5. So I end up with f take away 10 divided by 5 equals m. Brilliant. I have now rearranged the equation. Okay. But it says I need to work out the fare, work out how far the journey was, how many miles. So now what I need to do is just what I've done previously, substitute into the formula. And I solve it following BIDMAS. So I then have 46 take away 10 divided by 5. And when you've got, a funny, awkward, clunky looking fraction like this, if I treat this in terms of BIDMAS, if I treat what's on the top here as having brackets around it, that'll help me to remember to do that first. So 46 take away 10 is 36. So it'll be 36 divided by 5 is m miles. And who was quick off the mark there? Yeah, straight away, 7.2. So yes, you were correct. 7.2 miles. And I can see somebody's corrected themselves as well. Have we got any questions on there? Because I'm moving on from equations and formulae now, and I do know that this is something that people were quite, a lot of people put as a challenging area. This is not all there is to know about formulae or algebra, but I'm trying to cover just little snippets of everything. Is that helpful? Okay, got a thumbs up there, thumbs up. Thank you very much. Okay, perfect. All right then. Okay, now we're going to look at area. I plan to hold a party. I want to invite as many people as will fit in my home. I estimate that a person dancing in my living room will need 0.5 meters squared. Okay, little space about that big. My brother actually did this for an 18th birthday once. How many people can I invite? So here's my living room dimensions. Area for rectangles, quite straightforward. It's given by the formula length times width. So 4 times 5.5. Calculate the area. This can help, all right? Putting a squared grid on top. The area is the bit in the middle. Lots of learners get area and perimeter confused. So calculating the area, 4 times 5.5 is 22 meters squared, okay? But how many people fit in a meter square? So in each meter square, you will actually, because we've got a half meter by a half meter, we're going to fit 4 people in every single square. Okay, so in every meter squared, I'm going to fit 4 people. Therefore, 22 times 4 is 88. So I can invite 88 people to my party. Brilliant. Not really realistic, but my brother genuinely did this for a party once. Okay, so can you see where those who put 44 in the chat? It can be quite confusing actually, but you can fit 4 people in each meter square, so that's why it's 88 people, surprisingly. Okay, now the perimeter of anything, like I said, lots of learners get perimeter and area confused. Okay, the perimeter of anything is what goes around the rim. Okay, it has the word rim in it, the edge, it's the edges. The circumference is a particular kind of perimeter because it's the circumference is what we call the perimeter of a circle. So in this example, this is my actual Christmas cake. I've taken an actual picture. The cake's going to need a ribbon around it after it's been iced. There is a 65 centimeters piece of ribbon left over after wrapping presents. Is this going to be long enough? Okay. So I'm looking at the perimeter. I'm looking at the circumference. The circumference of a circle is given by a formula, and the formula is pi d, pi times d. So I need to know what d is. That's the diameter of the cake. The diameter is 22 centimeters. I then substitute into the formula. For the purposes of now, I can use an approximation of pi, 3.142, but if you have a scientific calculator, you can get the exact value of pi. But 3.142 times 22 is 69.124 centimeters. Do I have enough ribbon? No, I do not. I need to buy more ribbon. How annoying. Okay, next one, capacity. At my party, I'm going to serve mulled wine, and I want there to be enough for each of my 88 guests to have a small glass. Mulled wine comes in 750 milliliter bottles. How many bottles will I need? The first thing I need to know is what's the capacity of my cup. So although I could do that by calculating the volume of a cylinder, perhaps, more straightforward in my kitchen, I can just get a measuring jug and I can pour in and see how much is left in the jug. So the capacity of the glass, this glass in particular, is 150 mils. The total volume I need for my 88 guests. Okay, so the total volume we need is 150 milliliters times the 88 people. I've then got my total 13,200 milliliters. If I divide the total volume by the bottle volume, that will tell me how many bottles. So 13,200 divided by 750 gives me 17.6, which means I need to buy 18 bottles. If I'm lucky and there's a deal on, that's not so bad. But otherwise, 18 bottles, if there are 5 each, that's a significant amount of money. So perhaps I will just do this. Bring your own wine and I'll give you a pan and some spices to heat it on. So nice gift there, thank you. Okay, right, we're going to look at compound measures. In this example, relatives live 320 miles away and aim to arrive for the party, my party, at 6 p.m. If they drive at an average speed of 50 miles per hour, what time must they set off? So let's look at how we can solve this. Now, I quite often find functional skills teachers teaching this speed equals distance over time. And the triangle is actually quite helpful because no matter where you are on the triangle, you can work out the others because it's speed equals distance over time. You can see it's over the top. Or you could say time equals distance over speed because that's what it looks like in the triangle. Or you could say that distance equals speed times time because they're on a level with one another. Personally, I don't think you necessarily need to learn that formula or learn that triangle in order to do calculations like this because the words give it away. Miles per hour tells me I am traveling that many miles in 1 hour. Okay, so that already tells me that it is distance divided by time. Miles per hour, distance per divided by time, hour. So I don't need to memorize a formula because it's there in the words, miles per hour. So what I can do is divide the total miles by the miles traveled in an hour. So I've got 320 miles. I can go 50 miles in 1 hour. How many hours is it going to take me? So 320 divided by 50 gives me 6.4 hours. Now what I need to do is I need to work backwards from there, and I need to be very careful. 6.4 hours does not mean 6 hours and 40 minutes. 0.4 of an hour, when an hour is 60 minutes, needs to be calculated differently. So I convert the decimal hours into hours and minutes. So I know I've got 6 whole hours, but what is 0.4 in minutes? Well, 0.4 times 60 is 24 minutes. So this is how long it's going to be, 6 hours and 24 minutes. The latest time that I can leave, so I want to get there at 6 o'clock, I need to work backwards. So from 6 o'clock, if I work backwards, work backwards 7 hours, then that would give me like 11 o'clock. But I don't need to go 7 hours, it's 6 hours and 24 minutes. So 60 take 24 is 36. So I need to leave by 11:36. Okay, and this is realistic actually because I come from Oxfordshire but live in Newcastle, which does take a good fair while. So you didn't get the last part. So the last part is basically the latest time to leave. So 6 hours and 24 minutes. If I go backwards in time from 6 p.m, right? If I go backwards 6 hours, that brings me to 12 o'clock. But I need to do 12 o'clock minus 24 minutes. So that's why I've done an hour, take away 24 minutes, gives me the 36. So that gives me 11:36. Time, actually, I mean, this is compound measures, but it also deals with time. Time can actually be quite confusing. Okay, we've got just 3 more examples to take a look at. And so, scale. We've got a route planned for the Boxing Day hike. The route measures 16 centimetres on the map. How far is the hike in reality? I've got my scale, 1 to 25,000. Now, when you see a scale like this, 1 to 25,000, it means that one of anything on the map is equal to 25,000 of that unit in reality. So if I measure an inch, then 1 inch is 25,000 inches in real life. If I measure 1 centimetre, then 1 centimetre is 25,000 centimetres in real life. So for the purposes of this example, I've got 16 centimetres. So I need to multiply the scaled distance by the scale. So 16 times 25,000 means I've got 400,000 centimetres in real life. Now, realistically, it should say how far is the hike in kilometres, because we never say, oh, I'm off for a 400,000 centimetre walk. Doesn't happen, does it? So I'm going to convert it into kilometres. And the way that I can do this is I know that there are 100 centimetres in a metre. So let's turn it into metres first. So 400,000 divided by 100 is 4,000 metres. And then to convert the metres into kilometres, 1,000 metres is in 1 kilometre or kilometre. So 4,000 divided by 1,000 is 4 kilometres. Statistics. To reduce waste when planning the festive dinner for a group of 12, a survey of favourite vegetables is conducted. Can you imagine somebody doing this with you? And here's the survey. What implications does this have for the dinner plans? So I've done my survey. 4 people, their favourite is sprouts, and also parsnips. 4 people, it's their favourites. So when I'm looking at statistics, if you're dealing with functional skills or GCSE, it will tell you, it might give you very specific thing, you know, use the mode to analyze these statistics, or use the mean and range. All right, but in real life, in your vocational subjects, generally you have to know different statistical measures and you have to make the decision. So I could make the decision, since I want to reduce waste, I could make the decision that, what I'm going to do is, since sprouts and parsnips, these are the 2 modal values, because they appear most, I'm only going to cook sprouts and parsnips. I'm definitely not going to bother with cauliflower. That's nobody's favourite. Why would I bother with that? And a way to remember different statistical measures, so different ways of calculating average. You may have heard this. We've got hey diddle diddle, the median is the middle. You add and divide for the mean. The mode is the value that you see the most, and there can be more than one mode. And the range is the difference between. So that's a way to remember how to calculate mean, median, mode, and a range. But, right, if I make the decision that I'm only going to cook sprouts and parsnips and I'm not going to have any other vegetables, what it could lead to is lots of people being very unhappy. So when you are calculating statistics, and here's the same 12 people, instead of being asked what's your favourite vegetables, they were asked, which vegetables will you eat? If I put them on your plate, which ones will you eat? We then got these results. So 4 people, it's sprouts are their favourites. Unfortunately, there are only 4 people of the 12 who will even eat the sprouts. Whereas carrots, everybody likes carrots. Everybody likes broccoli of these 12 people surveyed. Everybody likes cauliflower. It's nobody's favourite, that's all. So with a different survey, I can get results that are more helpful. So as when exploring statistics with your learners, it's very important not just to be able to analyze data, possibly by using measures of averages, but also to ensure you collect or use the best data for what you're hoping to achieve. Okay, last question. This is another statistics question. And by all means, you can answer this in the chat, okay, because there's no right or wrong, really. Example, New Year can either be spent in Edinburgh with friends or in Newcastle with family. The decision will be based on the temperature between the December 29th and January the 3rd. Okay, so these are the temperatures for last year. We've got Newcastle and Edinburgh there shown in the table on the 29th, 30th and 31st of December last year and the 1st, 2nd, 3rd of January this year. How might this data be used to guide the decision? Where are you going to stay, Edinburgh or Newcastle? Let me know in the chat. For this one, I'm going to use the mean. Okay, so hey diddle diddle, the median's the middle. You add and divide for the mean. Okay, add and divide for the mean. So I need to find the mean. I need to add up all of the totals. So 3 plus 4 plus 3 plus 4 plus 3 plus 7 is 24. Yikes, it actually adds up to the same for Edinburgh, which means the mean, you add and divide for the mean. So 24 divided by the 6 pieces of data we have, 6 days, the mean is the same. So, wow, 6 and 2 threes, then I may as well, it doesn't matter where I stay. Apart from the fact that if we bring the range into it, the range in temperatures in Newcastle, and to find the range is the difference between. So the difference between the highest and the lowest temperatures, 7 take away 3 is 4, 7 take away 1 is 6. So the range tells me that although the mean is the same for both cities, the range tells me that the temperature is more consistent in Newcastle, or at least it was this time last year. Therefore, I might decide that I am actually going to stay in Newcastle rather than going to stay with friends. So using the mean and the range, that's what I might conclude. Although I might actually conclude that, come on, let's face it, it's quite an arbitrary way to make a decision. So again, think about the data that you're collecting. So this is what we've covered, and as I did say at the beginning, and I will pop the link on again, we do loads of CPD for maths. All of our CPD sessions are usually for functional skills teachers. However, you may well find that some of these fit in with what you teach. So in here, look, on-demand events, previous CPD and on-demand, we've got a whole YouTube playlist that some of it might be topic related, problem solving, but I'm sure there's one like integrating maths into apprenticeships. Could be useful for some of you who are asking about that. Planning, including roll-on, roll-off delivery, formula and bid maths. There's a whole session on there that might be useful to some of you who struggle. There's lots on here that you're more than welcome to have a little look at. Thank you very much. I'm loving all of your emojis. Apologies if running over time. I did do a little practice, but obviously it's different when you're waiting for people to answer. And I kind of wanted to give you time. So I'm going to pop that feedback form into the chat as well. We really do appreciate your feedback. We do listen. And if there's anything more, and particularly because I know there's a lot of vocational teachers here who I don't normally get to see. I live in functional skills land, and so if if you would find it more helpful, for example, in T levels, if you want some maths brought into that, let me know in the chat, in the feedback form. I'll be very happy to help. But thank you so very much for staying with me for this full hour, even though it was advertised for 45 minutes. And from myself and everybody at NCFE, I do hope you have a fantastic Christmas break. And whatever you're doing over the time off, you get to go on hikes and do cooking and think all the time. I want you to be thinking about the maths, okay?